Charles's law is a different law that has its own equation that basically helps to explain how gases in containers behave when you change the temperature. So again, this should probably be a little bit intuitive to many of you, but to explain it, I'm going to talk about a gas in a container. In this case, again, I will talk about a balloon. So I have a gas in a container. In other words, I have a balloon filled with gas. It has a volume that you could figure out if you were resourceful enough. The gas in the container also has a temperature, right? That the temperature of the gas in the container is some number. And what Charles's law says is that if you increase the temperature of the gas in your container, the volume will go up. And if you decrease the temperature of the gas in your container, the volume will actually go down. Again, this probably isn't earth-shattering news. If you heat up a balloon, usually the volume of the balloon increases. If you cool down a balloon, the volume decreases. And mathematically, what you say is that the volume of the balloon is proportional to the temperature in Kelvin. And so what Charles's law is saying in a little bit more detail is if you change the temperature in the balloon, you can figure out the new volume. Or if you change the volume in the balloon, you can figure out the new temperature. And all of this works operating under the assumption that you're not changing anything else about the gas. You're not changing the pressure on the gas, and you're not changing the amount of the gas in your container. So the formula for Charles's law is shown here. Again, I don't expect you to memorize these formulas. I would give them to you on a quiz or a test, but the formula for Charles's law is the initial volume of the balloon, V1, divided by the initial temperature of the balloon, T1, is equal to the new volume of the balloon divided by the new temperature of the balloon. And we can do an example in a couple of slides. I'm just going to show you a video showing you Charles's law in action on the next slide.
Okay, we've got some liquid nitrogen which is minus 196 degrees. Let's see what happens if we put that over an air-filled balloon. So the air's got really cold inside. Air, when it gets cold, gets smaller and cools down. Let's warm it up using the breath from my lungs.
Here is a problem that uses Charles's law and the equation for Charles's law. It says you have a balloon, so pretty much all of these problems are going to deal with balloons or something similar to a balloon. You have a balloon with a volume of 3 liters, so that's V1, and its temperature is 23 degrees Celsius, so that's T1. And you change the temperature of the balloon to 37 degrees Celsius, so there's T2. It says what's the new volume of the balloon? In other words, what is V2? So the formula for Charles's law is V1 divided by T1 equals V2 divided by T2. And if you look at this question, there is a slight trick in there, and that is that they gave the temperature to you in units of Celsius. And if you remember from earlier in this unit, I told you that when you deal with the gas laws, when you deal with these types of problems, you have to convert all of your temperatures to units of Kelvin. So we can almost do this problem as it's given, but we have to convert 23 degrees Celsius to Kelvin. We have to convert 37 degrees Celsius to Kelvin as well. So in reality, what we do is we plug in all of the information that we know into this equation. V1 is 3 liters, so we put 3 liters in the numerator there. T1 is 23 degrees Celsius plus 273. V2 is what we're looking for, so I'm going to call that X liters, and T2 is 37 degrees Celsius plus 273 so that we can get it in units of Kelvin. If we simplify this formula here, or that equation, we get 3 liters over 296 Kelvin is equal to x liters over 310 Kelvin. And again, all we have to do now to solve for x, to figure out what x is to cross multiply and divide. So we can do that. We do 3 liters times 310 Kelvin, that's shown here, is equal to 296 Kelvin times x liters, that's shown here. To get x all by itself, we divide both sides by 296 Kelvin. And doing that, x liters is equal to 3 times 310 divided by 296, which turns out to be about 3.14 liters. So, to summarize, you started out with a balloon that was at 23 degrees Celsius. The volume of the balloon was 3 liters. You increased the temperature to 37 degrees Celsius. So you increased it a little bit. If you increase the temperature, the volume should go up. And so what did we end up with a new volume? We ended up with 3.14 liters, which is a little bit bigger than 3 liters. So this basically confirms, hopefully, what you had expected. If you increase the temperature of the balloon, the volume will go up, and it actually did. It went from 3 liters to 3.14 liters. So another lesson here is that if you do this type of problem and you come out with an answer that doesn't make sense, in other words, if we came out with an answer where the volume was less than 3 liters, but we increased the temperature and we didn't change anything else, then you know that you did something wrong and you should go back and check your math. And so that's basically it for Charles's law. Charles's law deals with what happens to a gas in a container, what happens to the volume of a gas in a container if you change the temperature, or what happens to the temperature of a gas in a container if you change the volume. And that's it for Charles's law. The next law that we will talk about is called the combined gas law.